Is the universe truly infinite? Does it have an edge? And if so, what lies beyond? These questions have fascinated humanity for centuries, pushing the boundaries of both science and imagination. Modern astronomy offers some insights, yet the answers remain as elusive as they are intriguing. First, let's consider what we know. The universe had a beginning roughly 14 billion years ago in an event known as the Big Bang. From that singular moment, it has been expanding ever since. But this expansion raises a fundamental question. If the universe is growing, does it have an edge? And what might exist at such an edge? To understand this, we need to explore the concept of the observable universe. Light, the fastest thing in the universe, travels at a finite speed. This limitation means we can only see regions of the universe from which light has had time to reach us since the Big Bang. When we look out into space, we're seeing a snapshot of the past, stretching back billions of years. The farthest regions we can observe form a sphere around us, known as the observable universe. Its radius isn't 14 billion light-years as you might expect, but approximately 45 billion light-years. This discrepancy arises because the universe has been expanding, stretching the space between distant objects and us. Thus, the observable universe encompasses everything whose light has reached us, totaling about 200 billion galaxies, each containing hundreds of billions of stars. But what lies beyond this observable boundary? This is where things become speculative. Beyond the observable universe, there is more universe. Regions so distant that their light hasn't yet had time to reach us. These areas remain inaccessible, not because of physical barriers, but due to the limitations imposed by the speed of light in the age of the universe. In this sense, the universe's edge is not a physical boundary, but a horizon in time. The actual size of the universe could be vastly larger than what we can observe, or it could be infinite. If the universe is finite, it might have a peculiar geometry that allows it to have no borders. Imagine the surface of a sphere, like the skin of an orange. An ant walking on the sphere's surface could keep traveling indefinitely without encountering an edge. Similarly, the universe could be a three-dimensional version of this concept, called a hypersphere. In this scenario, traveling in a straight line through space would eventually bring you back to your starting point. While our brains struggle to visualize such a shape, the mathematics behind it is well established. Another possibility is that the universe has a topology akin to a torus or hyperdonut. In this model, space loops back on itself in more complex ways. Traveling in one direction might bring you back to your starting point, but at a different angle or with additional twists. This could lead to fascinating phenomena, such as light from distant galaxies traveling along multiple paths to reach us, creating a cosmic hall of mirrors. In such a universe, you might see the same galaxy in different locations in the sky, or even observe its past and future simultaneously. Determining the universe's true shape and size is a monumental challenge. Scientists have searched for evidence of a universal horizon or signs of space looping back on itself, but so far no definitive clues have been found. If the universe is a hypersphere, it would need to be at least 1,000 times larger than the observable universe for its curvature to remain undetectable. It could also be far larger, perhaps even trillions of times bigger. Alternatively, if the universe is a hyperdonut, its smallest possible size would be only slightly larger than the observable universe, but it could also be infinitely larger. So what if the universe is truly infinite? In an infinite universe, space stretches endlessly in all directions, containing an infinite number of galaxies, stars, and other celestial objects. This idea is both awe-inspiring and perplexing. For one, it implies that every possible arrangement of particles could exist somewhere out there, given enough space. This leads to the mind-bending notion of duplicates. Exact copies of you, Earth, or even entire galaxies could exist at unimaginable distances. However, the probability of encountering such duplicates is astronomically small, as the sheer scale of the universe makes these repetitions effectively unreachable. Infinity also raises paradoxes. If the universe is infinite, does it mean it has always existed? Could there have been a time when there was nothing, followed by the sudden appearance of everything? While the Big Bang provides a starting point for our universe's observable history, it doesn't necessarily explain what came before or whether infinity itself can start in a meaningful sense. Another paradox involves the expansion of space. If the universe is already infinite, how can it expand? Cosmic expansion doesn't mean that galaxies are moving through space like cars on a highway. Instead, space itself is stretching, increasing the distances between galaxies over time. Even an infinite space can become more infinite in this way, further complicating our understanding of infinity. In practical terms, our experience of the universe remains confined to the observable portion. Everything we can study, interact with, or explore exists within this finite bubble. Even with advances in technology and science, it's unlikely we'll ever access or comprehend the full extent of the universe, whether it's finite or infinite. Despite these limitations, the universe we can observe is more than vast enough to inspire wonder and discovery. With its billions of galaxies and countless stars, it holds an endless array of possibilities for exploration and understanding. From the smallest particles to the grandest cosmic structures, the observable universe offers a lifetime of mysteries to unravel. In conclusion, the question of whether the universe is infinite remains unanswered. Both finite and infinite models present fascinating possibilities, each with its own implications for our understanding of existence. While we may never know the full truth, the journey of exploration and inquiry continues to expand our horizons, reminding us of the limitless potential of human curiosity.